And welcome back to this follow-up on a screw thread that I cut earlier on to try and show how to determine the depth of a thread. Now I just want to make some additional comments in terms of what I said earlier. So all the theory I explained earlier is true, and basically the summarization of that was that if you cut a 60-degree thread to what's called full depth, that means that you cut it so that your pitch, in my case I'm going to be doing an M10 by 1, so the pitch will be 1 millimeter. So if you cut it to full depth so that this leg of your equal sided triangle is 1 millimeter, it means that all three those legs are 1 millimeter, and then essentially that means, by way of math, that the full depth of the thread is 0.866 millimeters. Now, even though that's true, if you cut a full thread, the problem is that the thread specification for an M10 by 1 does not ask for the thread to be cut to full depth. So let's have a quick look at that. What the thread specification does specify is the OD, so that's the OD of the part. It's also called the major diameter. It then also specifies what's called the minor diameter, so that's the depth of the thread, and from one side to the other side this depth. Now both the major and minor diameter is specified in a minimum and maximum value, so there's a bit of a tolerance there. If we take the M10 by 1 thread, and there's also different tolerance classes, but I'm going to be showing the tolerance class with the lowest tolerances as an example. So if we take those tolerances and the thread specification, we'll see that it's called the major diameter, the minor diameter, and if we take the max and minimum of each of those and we calculate the average between the two, then if we take the major diameter average and subtract the minor diameter average, that will give us the depth of the thread on both sides, because it's the difference between the OD of the part, or the major diameter, and then the minor diameter, which is the total distance from there to there plus there to there. That'll tell us how deep we have to cut the thread. So if we take the difference between the two and divide it by 2, it'll give us the single-sided depth of the thread. So let's do that for the M10 specification. Here are the figures from Machinery's Handbook. Now, Machinery's Handbook calls for the OD tolerance major diameter of an M10 by 1 thread to be 9.82 to 10 millimeters, and the average of that is 9.91. It also calls for the minor diameter to be somewhere between 8.622 and 8.917, of which the average is 8.77. So the difference between the average major diameter and the average minor diameter is 1.14 millimeters, and if you divide that by 2, it gives you 0.57 millimeters, which is the single side depth that you have to cut the thread to get to the specification. Now we do know that it's difficult to measure or determine the actual depth that you're cutting by using a commercial cutting tool, because they have radiuses on the end. So when you touch off on the part and it starts scratching the part, you don't know how deep you're into the part in theory already, given the radius or the flat on the tip of the tool, unless you know the specification of the tool. Now for my insert tools I don't, so when I touch off I have no idea what that flat is. I can try and measure it, but it's really difficult. So another way of measuring to the specification of the thread is to take what's called the pitch diameter of the thread. Now a pitch diameter of a thread is a imaginary cylinder that runs more or less through the middle of that thread. Now the pitch diameter for the M10 by 1 thread in the Machinery's Handbook is specified as 9.29 millimeters, and the thread or the pitch diameter you can measure, so let's also call this PD or pitch diameter. So you can measure that using the over the wires method. So that's where you put 2 wires on one side and another wire on the other side, and then measure over the wires, and then there's a formula that you can use to determine what this measurement should be for a specific pitch diameter. So again, Machinery's Handbook gives the formula for V-sharp threads as that measurement over the wires is equal to E, which is the pitch diameter, minus 0.866P, which is the pitch. So in this case it's just minus 0.866 because the pitch is 1, plus 3 times the wire diameter. Now in my previous video you'll see that I've used wires of 0.818 millimeters, which again is within the specification of wire sizes that you can use to measure a 1 millimeter pitch thread. And that calculation gives me a reading of 10.88 millimeters. Using, again, that's the average. There's a tolerance on the pitch diameter, but using the average pitch diameter, it gives me a reading of 10.88. I've taken a commercial M10 by 1 bolt that I also used in the previous video, and with struggling quite a bit to get the 3-wire method accurately measured, I got down to exactly this value. So it seems that the commercial bolt is actually made to specification for this tolerance bolt and in exactly the average value. So that's what I'm going to be shooting for. So what I'm going to do is I'm going to cut this thread by touching off the tool. Since we know that the theoretical depth to get to that specification is actually 0.57 millimeters, which by the way also explains why my previous thread was so loose a fit. It's because I went in the full 0.866 millimeters to full depth of the thread, which is not as per specification. So I'm going to go in about 0.5 millimeters and stop short of this because I don't know what the flat on my tool tip is, and then I'm going to start measuring with the wires the pitch diameter, and I'm going to go in until I hit that number, and then we'll see how it fits. When I'm doing that, I'm also going to be using the single wire method of measuring the pitch diameter, because trying to do it with 3 wires, unless you've done it 1,000 times, it's just almost impossible. I'm not going to bore you with the math of how you do that, but just very quickly, if you take the center line of this part, then essentially this is equal to the radius of the part, and that you can determine because you can measure the OD. Once you know the radius, then all you have to do is measure with your micrometers from the OD of the part on the one side to the outside of a single wire on that side, and then this distance, so from the center of the part to the outside of that wire, if you double that number or that measurement, it'll give you the full over the wires measurement. Since you know what the OD of the part is, therefore you know what the radius is, you can measure from the outside of the wire to the outside of the part using a single wire, and then just subtract the radius, take that result, times it by 2, and that will give you the full measurement, and it's that measurement that has to be 10.88 millimeters in my case. Okay, so it does require you measuring and doing a bit of math. It's not a direct reading, but it's so much easier than having to try and do the 3 wires and hold them together as well as measuring. All of this I got from, or a lot of this information I got from a video by Joe Pieczynski. So in the description down here in the video, I will link to that video of Joe Pieczynski. So let's go over to the lathe and try and put all of this into practice. Okay, I've already prepared a blank. The stick out is a bit more than what it should be, but I'll just keep on making spring passes until it doesn't cut anymore. So my compound is already set at about 29 degrees, and what I'm going to do now is cut a thread relief, a little groove into which the tool will drop at the end of the thread. Now I know that the thread should be about 0.57 millimeter deep, because that's what the specification called for. So that thread groove I'm going to make about 0.65 millimeters deep, just to make sure it's deep enough. The way I'm going to do that is I'm going to switch on the lathe, make the tool touch, and by the way I've also squared up the tool to the axis of the lathe. And then I'm going to make the tool touch, and then I'll be cutting in 0.65 millimeters just using my dial on the cross slide. Okay, so that's just touching there. I'm going to zero the dial and then go in by 0.3 millimeters. Come back to the start of the groove. So that's about 0.65 millimeters. So that groove is now should be deeper than what the thread's cutting depth is going to be. And I think just to be safe, I'm going to make it 0.7 millimeters. So that's 0.7. Okay, so and now I'm going to, if you look at the previous video, I've showed a way of actually making sure that you go in a specific depth. Now I'm going to go in by 0.5 millimeters total cutting depth, single-sided cutting depth, and until I start measuring over the wires. And the way I'm going to be doing that is explained in the previous video, so I'm not going to show you guys again. You will notice that I've got a different part in the lathe now. It's because on the last spring pass of the previous part I crashed the lathe tool, which moved the tool by a bit, and then when I went in to do the final cuts, it cross-threaded the thread. So what I've done is exactly the same as previously. I set up the part, I went in by a total of 0.5 millimeters, and now I'm going to measure over a single wire. I have cleaned up the thread, so I'm going to just measure over a single wire to see what the measurement is. I do know what the OD of the part is, so by way of a bit of math I should be able to calculate. So I'm getting 10.57. So 10.57 millimeters is the measurement over one wire. I'm going to take that, subtract 5 millimeters, the radius of the part, double the result, and that's going to be my current pitch diameter, and then I'll just figure out how much more I need to go. Doing the math as explained, I'm still 0.26 millimeter off of having the pitch diameter correct, so that means I need to go in by a total depth of 0.26 millimeters, which is 0.13 one-sided depth. So what I'm going to do is take my cross slide and move in by 0.13 millimeters, zero it again, come back out with the compound and start making more cuts until the compound is back to zero again, which means I would have then moved in that single-sided cutting depth of 0.13 millimeters, and then I'll bring you back and we'll do the measurement again. After making a number of spring passes until the tool didn't cut anymore, I'm now to full depth using the calculations as per Machinery's Handbook. What I'm going to do is just measure the thread over one wire and do the math to figure out what the pitch diameter is, the actual pitch diameter. So I'm getting a single wire measurement of 10.44 millimeters. Let me quickly go and do the math and figure out what measurement over 3 wires that would give me. So the 10.44 millimeter single wire measurement, doing the math, actually comes out to be exactly 10.88 millimeters over the 3 wires, given my wire size and the calculations I showed you earlier on. And that is exactly spot on in terms of the specification, as well as in terms of what I've measured with the commercial bolt. So I haven't tried the nut yet, but just this nut goes onto the commercial bolt with very little play. It's a very nice fit. Now let's see, without having ever tested the nut on this part and just using the math as I've done, let's see if this fits. In fact it does, and it's virtually got no play. I would say it's got even a little bit less play than the commercial bolt, but very close to the same fit. I think that's a perfect fit. So I'm very happy with the way the math and cutting a thread to specification has worked out. I do know now also that with my specific tool, if I use the same insert, I need to go in a total of about 0.62 millimeters from when the tool touches off until I've reached full depth. So in future I'll make a note of that, and in future when cutting specifically M10 by 1 threads, I'll use that 0.62 single-sided cutting depth as my measurement. Then I don't have to measure over the wire and come back in again. I can just cut the thread to specification in one go, and then for all the other threads, as I cut them, I'll make notes of what that same value is for the different other threads.